Hi, my name's Sonya George, and I'm a teacher at Union Parish Elementary School in Union Parish. As a teacher, I'm passionate about students becoming confident, lifelong thinkers, and not afraid to take on complex challenges, problems, and ideas. The students on this video will be fourth grade students, and I'll be teaching math. We're using the Zern Tier 1 curriculum. The objectives for this lesson, we're on Mission 5, Lesson 9, will be to use the area model and division to show equivalent fractions. We're on our focus standard 4.NF-A1. I prepared this lesson by thinking about annotating our lessons, going through and making sure I'm covering all ideas that are needed to be taught for the standard. Taking notes, getting manipulatives ready. I created some modified worksheets for students that needed it. And our overall goals for Mission 5 is to learn about fractions, and fourth grade mainly identifying, creating, comparing fractions. There'll be 19 students in this lesson today. Some are 504 students. There's some English language learners. One is a mainly non-English speaking, but who is a very good student and prepares. Like I said, the modifications, you'll see some fractions tiles, modified worksheets for today's lesson. Working on Mission 5, Lesson 9. Remember our standard. Explain why a fraction, any fraction, is equivalent to a fraction, any fraction, by using a visual fraction model. And we're paying attention how the number and the size of the parts differ even though the two fractions are representing the same size. And remember our denominators that we're on this year. 2, 3, 4, 5, 6, 8, 10, 12, and 100. Remember the 10 and 12 are mainly on decimals when we get to that. All right, today you're going to use the area model and division to show the equivalence of two fractions. Illustrate and explain your work. Now today we're focusing on division. Need everyone's eyes up, please. Thank you. All right, so let's look at our success criteria. We're focusing on our standard NFA1. What should you be able to do by the end of the lesson? Use the area model and division to show the equivalence of two fractions. So look at your strategies you can do today. Draw two area models that are equal in size. Partition the area models to represent the fraction. Compose them. Now, we've been decomposing, correct? So what is composing? Making them, what did we say last week? Last week we were making fractions, what? Smaller pieces, but there are more of them? Okay, so let's think about division today. Compose them, so we're going to be building them back up in a different way, and they're still going to be the same size. All right, so we're going to start our fluency. Go and get your whiteboards out very quickly and draw me an area model that represents 2/3. 2/3. Say the fraction as you're drawing it. How many? 2, what? 2/3. What goes at the top of our model? What goes at the very top? The number 1, because we're talking about one thing. So let's go ahead and put on 1. What is a unit fraction?
A fraction of 1/5.
Okay, so we labeled each one what? 1/3, 1/3, 1/3. Everybody got those? All right, go ahead and write me a multiplication sentence that represents the fraction. What would we write? 2/3. Go ahead and write 2/3 again, just like Zern asked you to. Now I want you to draw a horizontal line right down the middle, and you're going to create an equivalent fraction. What do we notice about our pieces? What do we notice about our pieces?
The pieces haven't changed, but the numbers have.
So are we going more pieces or fewer pieces?
More pieces. No.
More pieces. But what about the size of them? They are larger or smaller?
Smaller.
Smaller. Okay. So what is the denominator? What is our total amount now? 6. So what is the factor you used?
2.
You doubled each piece. So what is your new fraction, your equivalent one? 4, 6. Very good. Okay, go ahead and erase. Alright. I'm going to put your whiteboard up. We're going to go to our next. We're kind of been going on our fluency. So let's go ahead and move on to our next part of our agenda. We're going to look at your word problem. Are we ready? So open up to your word problem. We're going to read it together, and I want you to think about what they're asking you. What do you need to know first? Ready, table 5? What fraction of a foot is 1 inch? What fraction of a foot is 3 inches? And they gave you a hint. Remember, we're kind of moving back to measurements later, so we're going to give you a hint. 12 inches is 1 foot. So you're going to draw a tape diagram to match this and model your work. So go ahead. Some of you started during bell work while we're waiting to start. Go ahead. So we just talked about how we created fractions for a foot, and what if we're talking about 3 inches? All right, so we're going to go back. We're going to be thinking about using division. So I want you to think about this. What fraction do you see here? What is this fraction? What's our denominator?
6.
Okay, and how many are shaded? Now this is equal to 1 fraction, so I want you to draw this on your notes. Remember, a fraction doesn't have to be, and I gave you one just in case. Look at this one. Now a fraction does not have to be one side. This looks kind of like it's horizontal. A fraction can go vertical. So I want you to draw this very quickly. Go ahead and pick a crayon up, and we're going to use this to divide. So go ahead and draw your 6/12. I want you to shade. You don't have to number it yet. I want you to partner after you draw. After you draw and shade it. I want you to partner it for a moment and talk about, can you create an equivalent fraction that has fewer pieces, but they're bigger? So if you looked at your fraction, we had 12 pieces. Now, did we change the shaded or unshaded once you circled it? Did you change the shaded? Did you shade any more? Did you erase any of that? So let's write a division equation. 6/12, what would be a, well, a moment ago you said there were 2 pieces. So what is the common number that you use to divide by? How did you go from 12 pieces to 2 pieces? Say it, let's create, ready? We created
We created
an equivalent fraction by using division on the numerator and the denominator. All right, what was the common number we used? 12 divided by what gave us two pieces? All right, so you use the same one. So what is 6 divided by 6? 1. What'd you notice about our pieces? They went from a lot of pieces to fewer pieces. All right, but they're big pieces. Okay, let's go ahead and write a division. So could we say, everybody write yours, 12 divided by 6 gave us 2, correct? So here's our unit fraction. Unit member is 1 on the top. We've been talking about how to explain how fractions can be composed. You just composed a fraction. We just talked about, and somebody just told me that you can rename a fraction, and they go from, you can decompose them and break them into smaller pieces, but there's more of them, into composing now. A lot of pieces turn into fewer pieces, but they're bigger. All right, so let's go ahead and go to the next part of our agenda. Let's go ahead and look at your exit ticket. Go and get your exit ticket out. Make sure your name and today's date is on it. And you can go ahead and begin. We're at the end of the lesson. Overall, the objectives were met. 75–80% of the students were able to identify or create identical fractions. Today, using division mainly. We've been working on multiplication, but now our first lesson on using division. I think next time I would probably allow more time for students to partner talk, to have a little bit deeper thinking and increase engagement, I believe would be a help. After teaching the lesson, we're going to continue to create equivalent fractions. We're mainly, like I said, focusing on division right now, but we're about to move into using benchmarks to compare fractions. So that'll be our next portion of Mission 5.